Hello students, I am Dr. Anusha Venkatachalapati, Associate Professor in Department of Orthodontics, Vinayaka Mission Sankaracharya Dental College, Salem. I am here to teach the topic on basic concepts of growth and development. As you can see in this picture, the first slide talking about a growth of a small tree, where you can see in the upper left corner a person is dropping waters, and this water droplets helping in a small seed to become a complex structure of a tree. Likewise, if you see the second picture, the picture is showing how a strawberry is being growing and then become a fruitful fruit to be eaten. And the third picture, you can see some structure looks like a rat which becomes a baby. It is nothing but a structure of an ovum that gradually grows into different stages of human being and finally as a baby. So, what is the growth? The definitions of growth goes into various ways of definition and given by different people. Todd has given the definition of growth as an increase in size, whereas Moss has given a definition of changes in any morphological parameter which is measurable, whereas Moyers has given it as a quantitative aspect of biologic development and is measured in units of increase per unit of time. Whereas Profit has given us usually growth is to increase in size and in number, and Huxley has told it as self-multiplication of living substance. As you can see, various people has given various definitions. Some people attribute the growth as into just increase in size, whereas some people talking in terms of a measurable parameter which is a morphological, or which is in terms of unit of increase per unit of time, or it is just mere increase in size and the number. Whereas there is a second aspect which is called as development. What is development? Development is progress towards maturity. That is what given by Todd. And Moss has given it as development can be considered as a continuum of casually related events from fertilization of ovum onwards. Whereas the Profit has given development connotes an increased degree of organization. Not only these three people, but also multiple people have given various definitions of development. But the point to be understood over here is craniofacial growth has two aspects. One is growth, another one is development. So the growth is largely an anatomic phenomenon, whereas the development is physiological and behavioral. When I repeat, the growth is largely an anatomic, that is more attributed to the structural changes, whereas the development is physiological and behavioral. That means more it is attributed to the function of an organism. It is not about a mere increase in size of your structures, organs, but more integrated with its function. So we can conclude in this way the craniofacial growth and development altogether. There should be growth initially plus differentiation of tissues plus translocation. So the differentiation, we have come across a new terminology over here. What is differentiation? This is a change from generalized cell or tissue to more specialized kinds during development. So, as we all know, initially we begin as a single cell and then gradually multicellular structure. We have come across something called pluripotent. Pluripotent cells are nothing but those cells capable of dividing into a different kinds of cells. That means they can able to perform different functions, though the parent cell is the same, whereas their next generation of cells can able to perform different function. That is what this terminology differentiation into specialized kinds during development. Whereas the very important terminology is maturation. Maturation is more about the quality. That is, it is not just increase in size which you can relatively measure as mass or unit of time, that increase in a height or a width. The maturation cannot be measured in such way as quantitative parameter, Rather, it is measured as qualitative parameter. So this is the qualitative change which occurs with aging, and it is not measurable in any dimensional senses. So the very important aspect of this today's topic is the factors affecting growth. Almost this forms the first half of the today's topic. In the basic concepts of growth and development in craniofacial region, we can broadly divide them into factors affecting growth, and then there are certain characteristics of craniofacial growth. So these two forms the major two aspects of the basic concepts of growth and development. Factors affecting growth. You can see over here almost 11 factors as being enlisted in the slide, right? But we have to see one by one so that you will get to know how these factors are actually influencing. First point is, you can see there are 11. That means the growth is being affected by various factors. To put in other terminology, multifactorial. We cannot assume that only one aspect is being influencing the growth so long. So we will see one by one. Heredity. We know the terminology heredity more as a genetic aspect rather than heredity as such. As you can see in this picture, there are two adolescent boys sitting over there, right? Both are merely looking alike, but they are not the same. We can able to appreciate few differences in their face. Like the boy on the left side is bit more stout. His attitude or maybe his nose or the face is little bulkier compared to the boy on the left side. Though they are looking alike, still there is some variation between them. What is the meaning? As you can see on the left side, we have two terminologies written at the top: dizygotic, monozygotic. That means the dizygotic twin, monozygotic twin. These boys are an example of a dizygotic twin. What is the meaning of dizygotic twin? Although they are twins, that means they have been fertilized and they have been grown in the womb and they have been born for the same mother during the same period in the same womb. But you can see in this area that there are two different ovum has been pierced by two sperm, and then this give rise to one baby and this give rise to another baby. So dizygotic twin means though they are twins, but these babies have been fertilized and formed by two different ovum and the sperm. Whereas the monozygotic twin, in this case, if you see here, they are called as genetically identical, whereas here they are called as genetically distinct. Why they are called as genetically identical? Because initially there is only one ovum and one sperm. They give rise to a zygote and the zygote splits into two. So their genetic makeup is going to be the same in this monozygotic twins. So this is importance of heredity, how it is going to affect a person's growth. Whereas the second point is nutrition. We all know how essential it is to have nutrition. As you can see in these pictures, a very famous picture from the African country where starvation and malnutrition was very severely affecting some part of the Africa. You can see how poorly nourished these children, actually they are looking for some food in order to save themselves. So this malnutrition is going to affect a person's growth. And the third point is illness. If you see the illness, we all know how this COVID-19 affected our life like anything. We all been suffered a lot during COVID-19. Our immunity went down so drastically. We are facing difficulty in breathing and even the day-to-day activities. The same way, illness could drastically affect the growth and development of craniofacial region. One such example could be if the baby is being affected with polio. Polio babies, you know it, right? Though the polio has been completely eradicated in India, still we know how the effect of polio would be in a baby. And the fourth factor is race. If you see this picture, you can appreciate a set of children at different ages happy and smiling, but one baby in this left corner, let's say this baby is looking nearly like an African, which we can figure out by the characteristic features on her face and the hair and the color and complexion, whereas a second baby looks more like a continental, like a side oriented with Philippine or Japanese, and the third baby looks more like some Asian baby, and the middle one looks more like an European, whereas the left side corner baby looks more like an American. So we can able to see, though they are almost looking like in a similar age, but they don't look alike. They are all different in their look, probably in their height, in their weight. The reason being they are all from different continent or different race. So that is how the race influences the growth of craniofacial region, not only just the overall growth. And the fifth factor is socioeconomic factors. We all know the high socioeconomic people can able to avail a very wide range of nutrition, whereas the low socioeconomic people are struggling to get even an average life, average nutrition. So the availability of wide range of food and nutrition is going to in turn affect the growth of different people in the different socioeconomic category, whereas the family size and the birth order. We know this factor, I think, quite right. Those people who are in a second order or a third order, they would understand how difficult it is and how we are being treated a bit differently in respect to an order. When the first baby is born in our family, we will be cherished, like everyone will be happy, oh this is the first baby, a little bit more pampered. And whereas the second, third and fourth baby, if the number goes on, sometimes what happens, the attention will be reduced to the baby. So the mother or the parent will not be in a position to give as much attention as they would have given in the first baby. So the family size and birth order is going to again affect. It is not only the growth in terms of physical, but also psychological development, and the social well-being of the individual will be affected if there is a large family or if it is a nuclear family. The same way the child which is born as a single baby or having as a fourth or the sixth in order. Whereas the next is your secular trend and the climatic and seasonal effects. When it comes to climatic and the seasonal effects, as you can see in this picture, the earth has been divided into different sectors like tropical, subtropics and mid-latitude and then polar zone. Usually India falls over here. The people in India is being considered, especially the southern part of the India, from the mid to the southern part, somewhere from Maharashtra over here and somewhere from until Orissa over here on the east. So these people is being considered as from the tropical country. That is, we have been almost having 9 to 10 months of summer and couple of months like 2 to 3 months of winter, and usually it will be more of rainy season rather than winter season. So the people from the tropical country used to be having a totally different genetic component, and their characteristic or so-called phenotype would be different. So their body will be more adapted to that higher temperature, whereas the people from the polar zone or otherwise mid latitude, we would say, because it is difficult, very difficult to survive in polar zone. Sometimes they call the country like Canada and all as just a cold desert. Nothing is there but just a cold desert. So people in the polar zone, for example, people are in Canada or some southern part of Australia or southern part of North America. The people from the polar zone, for example, some of the people in the Canada, they would be having their phenotype or their body tissue and the type of tissue which can be more adapting to that particular minus 20 degrees Celsius or minus 30 degrees Celsius, such a freezing climate. That is how we can able to see how the climate and the seasonal effects, like people in India will be more sweating and will be having more melanin production in order to withstand the temperature, whereas people in the polar zone such as like in Canada will be having such a quite opposite structure or features, like they will be having more of fat tissue, so they can able to withstand that such kind of extreme cold climate. And the psychological disturbance, exercise, very easily we can denote. How the psychological disturbance? Simply we can attribute this factor as even as an adult, not during just a growth and development period. Some people who fell ill, like in depression, used to heavily eat and try to compensate the depression by means of overeating. Whereas some people who are ill and depressed and things are not working out, then they tend to completely deprive of food and they will suddenly lose weight like anything. So that is how psychological factors are indirectly related to our lifestyle and food habits, and in turn it affects our growth and development. Whereas exercise and adult physics, as simple as like the people or person who goes to gym will be having better physique compared to the one who is very lazy and lethargic. So I think we have completed almost all the 11 parameters of factors affecting growth. Here just a small revision. The first factor is heredity, as we cannot avoid the genetic composition of an individual. The second factor is nutrition, which is very essential environmental factors, and then illness, the race or ethnicity, socioeconomic factors, family size and birth order, secular trend, climate and seasonal effects, psychological disturbance, exercise, and then adult physique. And the next half of our today's topic, which is about the concepts in growth. As I told you, there are three important concepts: pattern, variability, and timing. When it comes to pattern, again it is being divided into three different aspects: cephalocaudal growth pattern, differential growth pattern, and predictability. Whereas when it comes to variability, it can be explained in terms of concept of normalcy and timing. Nowadays it has been like a fourth dimension in life. We cannot exclude the impact of timing. So in this light, what are you observing? We can see that there is beautiful Banaras saree a woman is wearing with blue color, and another chungudi type of saree, probably from South India, in a beautiful lavender mixed with blue color. Whereas another woman is having, I think, pre-wedding mehendi over here, and a bunch of men enjoying their celebration during Manyava shooting. So what is the common factor in all these pictures? I know I have mentioned it here. This is pattern. So every single structure or every single object in the nature has something called pattern. What do you mean by pattern? We can define it as like a set of constraints operating to preserve the integration of parts under varying conditions through time. Pattern in simple term reflects a proportionality. As you can see in this blue color saree, what we can observe here, I think there is a flower which is getting repeated, and the flower is being connected by stem and having leaves in between, right? Throughout the saree, I suppose this is what has been getting repeated again and again. So there is a flower, there is an interconnecting stem, and we have leaves over there. So all these three things are getting repeated in a particular order or in a proportion. The same way over here you can see there are blue check, there is a white check, and then there is a pink or a lavender check, and we have straight lines over here. So this pattern is getting repeated in a particular manner. That is what is pattern. So in simple terminology, the pattern is, in other words, physical arrangement of the body at any time is a pattern of spatially proportional parts, and pattern of growth refers to changes in the spatial proportion over time. So initially if you see the pattern, it is just the physical arrangement at particular time, whereas pattern of growth, when you say the word pattern of growth, then how this particular pattern is eventually or gradually changes in its spatial proportion over time. So let's see it over here. We have two set of picture. One picture is about a baby girl, another picture is about baby boy. So this baby girl is eventually become a toddler and a girl and then teenage and then in her adulthood. The same way the baby boy is now eventually growing from being a baby boy to a man. Now what is the main observation we can see in both the pictures is when a baby boy is small and crawling, see the proportion between the size of the head and the size of the remaining parts of the body. Whereas become a toddler and in this height, what is the ratio or the proportion between the head and the remaining parts of the body? When he becomes a boy and becomes a teenager and becomes a man, the amount of head contribution in the overall height of the body, if you see, this is gradually reducing. Your limb, the trunk and lower limb gradually increases in size and they contribute the majority of the parts compared to the head size. So this is what is change in the spatial proportions over time. Does this happen within a year or two? No. Probably this baby is around 1 year old and this man is around 20 or let's say 30 years. So over a period of 20 to 30 years, this change of proportion had occurred. That is what about the growth pattern. If you see this, as I told in the beginning, we have two aspects. One is cephalocaudal gradient or cephalocaudal growth pattern. Another one is Schemann's growth pattern, which is otherwise a differential growth. So we will see first what is cephalocaudal gradient. Cephalocaudal gradient, here an axis of increased growth extending from head towards feet, that is head towards feet. You can see in this picture a 3-month fetus. The x-axis is holding the age, whereas the y-axis probably the height of an individual. At 3 months fetus, if you see the ratio, the head is almost half, whereas at birth, if you see, it is about 25% because it has been in 4 quarters, right? Whereas 1 year, it is perfectly at 25%, whereas 3 years, it is somewhere around 20%, whereas at 13 years old, it looks somewhere around 15%, and when the baby becomes a man, it is almost 12 to 15%. So what happens? The growth is gradually increasing more towards the feet compared to the head. The word cephalocaudal gradient, cephalic, which is pertaining to your brain or neural component. Caudal, which is away from your head or your brain. So this is what the cephalocaudal growth gradient or a very important aspect in the overall growth, as well as the same concept is applying in craniofacial growth. How it is being applied? Now the question is that, let's say an example of this head region alone. You can easily observe this in the entire body. Now we will see how it is applicable in craniofacial growth. In craniofacial growth, we have taken two skull, right? Craniofacial. We have a cranium and we have the facial part. So the changes in proportion of head and the face during the growth. If you see the overall height, we try to see it as 100% as overall height, which is from your vertex point to your menton point, which is menton is the lowest point in the mandible, vertex is the highest point in the skull. So when these two portions is being compared, you can see during a birth, the skull is occupying almost more than 2/3, whereas the maxilla and mandible is being occupying only 1/3, whereas in an adult skull compared to at birth skull, almost half. That is 50% is being given to your cranium, whereas 50% is for your facial bone, which is maxilla and mandible. What had happened in this case? Vertically increase in growth in maxilla and mandible. This vertical growth is contributed by your eruption of teeth, the alveolar bone, condylar growth and the ramal growth. So one should be in a position to understand these changes compared to the at birth to the adult skull, the vertical growth of your mandible and maxilla drastically increasing and contributing 50% of the height of the overall skull. So that is how the structures in the caudal area. This is structure of cephalic, this is structure of caudal, that is away from your cranium. So the mandibular growth is the main component and that is contributing to increase in the height, fulfilling the criteria of your cephalocaudal growth gradient. That means the structure which is away from your cranium and the growth occurs more in those structures, fulfilling it as cephalocaudal growth gradient. Now the second category is differential growth. The word differential we can see, that means something is different, differential, I mean they are not same. So if two organs are there or two people are there, they are not going to grow in a same manner or at same level or at same timing. Something is not same, right? So we will see what is not same over here. Different organs grows at different rate to different amount and at a different time. Here everything is different, nothing is same. What they are trying to say in differential growth is the different organ grows at the different rate. So the amount of increase in size is going to be different, different amount and different time. See, the second terminology is different amount, whereas the first terminology is different rate. What do you mean by the different rate? That is within particular time period or at that particular time, how much growth had occurred is what is the different rate, that we will see eventually in the velocity curve in upcoming slides. But you remember that the rate is different and the amount is different and at a different time it will be growing in a different way. So that is what the differential growth is. So the growth is definitely not an orderly process, but sudden acceleration, sudden deceleration, suddenly there is no growth at all. It's going to be a rough roller coaster here onwards. So the spurts, there is something called spurts. The growth spurts occur at times with increasing importance of orthopedic concepts and growth guidance. This is about the clinical aspect. But to learn more about this differential growth, there is an example of Schemann's growth curve which we will see. There is a graph over here. Y-axis is having percent of adult size, whereas x-axis is having birth, that is years, the age. There are four curves in this particular graph. We can see the tallest one, which is lymphoid tissue, and the plateau, something which is having a middle plateau, which is a neural, and a more curvier, a kind of S-shaped is the general, whereas the reverse plateau and with end region having an acceleration is mentioned as genital. So if we take ourselves, means any human being, whatever the tissue in their body, divide them into these four categories. One is lymphoidal, another one is neural cells and tissues, and the general body tissues and organs, and genital tissues and organ. If we divide them into four components and then observe them from birth to about 20 years of age. Why 20 years? Because post-adolescent or post-pubertal age is the one which we expect that majority of the growth would have been completed. So from birth till 20 years, when they observed these four tissue components, they have noticed that the lymphoid tissue has reached its peak. So we know it, right? This is the percent of the adult size. So this is the peak. This peak had occurred somewhere around 10 years old, whereas the neural tissue has reached its peak somewhere around 6 to 7 years, whereas the general growth initially increased here, again little bit of drop, again it has reached its maximum around the age of 18 to 20 years. And then the genital, if you see this genital organs or tissues, they are almost having negligible growth until the age of around 12 to 15, and sudden acceleration happen until the 20 years. So this depicts us different tissues grows at a different time period and a different rate. Now if you see that the growth curve of maxilla and mandible, this lies somewhere between neural and general. Let me draw it over here. What did they say? The maxillary growth curve lies somewhere between neural and general. So this is what maxillary growth curve looks like. Okay, whereas they have mentioned the mandible near the general tissue curve. So somewhere here, it could be either below or it could be a bit above, because it is near. It can be either above or below. So this is how the mandibular growth curve. Even in this case, we can able to observe your maxillary growth curve is more close to your neural curve. That means in turn it is fulfilling our cephalocaudal growth gradient pattern. So the musculoskeletal tissue grows faster than brain and CNS, and the substantiate concept of cephalocaudal gradient. That's what I said. Wow. So the next is today's match prediction. Anybody is interested, as CWC is going on and India is really rocking among the globe. Everyone will be liking to predict the future, right? Everyone is very curious about knowing and predicting the uncertain future. Medicine field and craniofacial growth is not an exception in that case. So the predictability is another important aspect of learning, knowing and doing in-depth research in the growth of craniofacial region. If you don't apply it clinically, then there is no point of knowing them, right? So the predictability is one of the very important concepts of growth and development, because we would like to know when the mandible is going to grow its maximum, when the maxilla is going to complete its maximum growth. Because if we know what is the right time, then we will be in a position to know when to intervene, when to correct a deficiency, how to improve the length of maxilla or length of mandible. So in order to know if it doesn't grow at its time, then we should be in a position to correct it, maybe promote or enhance its growth. So that is why predictability of the growth in the pattern of your craniofacial growth is very, very essential aspect. The next is a beautiful series of girls standing in an order, but one obvious thing to notice over here is definitely this picture is not to mean complexion. It is just to make your observation that all are almost in the same age. Actually they are in the same age and they are nearly from the same region. Still they look different, not just because of the complexion, but also try to observe the various factors, the size of the eye, their head ratio and their neck length and their different aspect of the proportion of face. So irrespective of from the same region, same area, same ethnicity, same age, still they all look different. One factor could be heredity, but there is something called variability irrespective of any factors which we described before. Even if you try to balance all those factors in the same way and try to maintain the same in every single individual, still every individual has a tendency to have difference in their growth and development. So the variability expresses quantitatively the range of differences found in large population of individual. There be in the similar age, sex, socioeconomic status, background, race, as I mentioned right in this picture. So this is the law of nature. Because of infinite number of genetic possibilities, no two individuals could be same. So before categorizing people as normal or abnormal, it is very important that we should understand there is slight amount of deviation which is possible from so-called normal pattern. So this can be done by evaluating a given child relative to its peer on a standard growth curve chart. The most commonly used to the growth chart is height and weight chart. For that, first you should understand what is normal. I said right, comparing it the mild deviation from normal or comparing into the normal peers. Everywhere we use the term normal. Nowadays even the social media has been considered, it's very normal. One point of time social media was not there at all. So now it is mandatory to have an account in at least one of the social media, right? So now it is considered as normal. The tag of normal has been given. If we take a set of range of values and then you arrange them, if that value is following this kind of a bell-shaped curve, this has been used in statistics, then it is being considered as so-called normal. Anything falls within this range of 67 to 95. The inner lines are depicting 67%, whereas the outer two line depicting 95%. So any value which falls within this range, that is between 95% of either side of the 0, is being considered as normal. Anything beyond this range is considered as abnormal. And another important factor is timing. So the variation in timing occurs mainly because of the biological clock or circadian rhythm. Like not every child, an example I am giving, not every child at the age of 10 years old, maybe in the class of let's say around 6th standard or a 5th standard, will be having same height, weight. We know that. But apart from that, if you balance every single other factor also, still they won't be having the same level of genetic potential to grow. Another example is not everyone will be having their menstruation at the same age, right? Somebody at the 8th class would have already had their menstrual cycle, but somebody wouldn't be having, right? So why that is happening, irrespective of you balance, like you balance all other factors, still their process is not happening, the biological even haven't happened in their body. Why? That is what this circadian rhythm or the biological clock which is set in their own body plays a role. Variation in growth and development because of timing are particularly evident in human adolescence. Some child grow rapidly, whereas some child are slow grower. In other term, they use early maturer and the late maturer. For example, they are telling failure of fusion of facial parts resulting in a well-known facial deformity, that is cleft lip and palate. Usually the cleft lip and palate happens weeks between 8 to 12. So if there is no closure between two parts of your maxillary process, then we are going to land up in cleft palate. Another example is growth spurt. As the rate of growth is not constant throughout the life, during certain period there will be sudden acceleration of growth, whereas certain period there is no growth, and those accelerated phase of growth is called as growth spurt. As you can see, there was a famous study done in Burlington. They have seen and observed that these are all the certain peak acceleration of growth, that is general growth. It includes your somatic tissue as well as the skeletal tissue. In male and female, there are three peaks: first peak, second peak and the third peak. In the first peak, if we see, it occurs at 3 years of age in both male and female, whereas the second peak occurs little early in female. See, it is only 6 to 7 years, whereas in male, the second peak of acceleration of general growth occurs at 7 to 9 years old, whereas the third peak occurs at 11 to 12 years in female, whereas 14 to 15 years in male. Here also you can observe that there is a difference in gender. There is sexual dimorphism, which is called as sexual dimorphism, that is male and female has different features in respect to growth. As second peak, third peak occurs early in female, whereas it happens late in male. So we can call female as early maturer compared to male, but also within female there could be early and late maturer. Some people might have this third peak little early, around 10 years. Some people might have it after 13 years. That could be possible. So there is considerable deal of individual variation in maturation. As I told, the second years earlier in girls and compared to the boys. The clinical implication of growth spurt, if you see, utilization of the growth potential and the orthognathic surgery. If suppose a person is having deficient mandible, we try to modulate the deficient mandible by advancing the mandible, try to catch up the growth of the mandible with maxilla and try to increase the length before attempting surgery. Surgery would be an option after the growth completion, but before that we would like to correct it using myofunctional appliances in order to correct the deficient jaw. That could be only possible if we tend to know this growth spurs, when is the right time to intervene. So I am going to apply this concept of normalcy again in terms of analyzing growth chart. What you are observing here is in red color is 2 to 20 years old girls growth chart, whereas in blue color it is boys growth chart. We can see there are two graphs. One is stature over here and weight over here. So in the graph x-axis is the same, it is 2 years old and then till 20 years, whereas the weight, it is gradually increasing somewhere between here, that is your 30 kgs, here it is 10 to 15 kgs, and then it is eventually reaching somewhere around the range of 65 to 85 kg, whereas you can observe here 5%, 10%, 20%, and then again it is going in the reverse order as 100%. Okay, so if the person is being considered normal if he is falling in this mid range, who is not this extreme in the upper hand or who is not in the extreme in this lower end, neither in the upper end nor in the lower end. The person is being considered normal who is falling in this particular range, which is from 10 to 95. The same way it is applicable in the boys chart also, whereas this is weight for the age, whereas what you are having is height for the age. So 80 centimeter, 85 centimeter, 90 centimeter, and then 95 centimeter. So this is the centimeters, the height of the individual at the age of 2 years old, whereas at the age of 20 years their height reaches somewhere around 150 to 175 centimeters. So if the person's height is considered as normal, if he is being measured over a period of time from 6 years to around 12 years, and then he is falling within the range of this 95 to 10. Anything less than this is considered as abnormal, anything beyond this considered as again abnormal or otherwise syndromic. So two more important graphs we should understand when we try to measure about this height and weight and interpret the same in terms of your craniofacial growth. Here you can observe one more graph. X-axis again having age, whereas y-axis having height in centimeters. If you see the age, it is 0 to 18 years, whereas the height it is 0 to 200 centimeter. There are dots. They are using this from or just at 1 year. Gradually they are measuring the height and they are denoting in coordinates and connecting this. So here you are having a continuous increase in this particular line. It starts from somewhere around 0, it reaches somewhere around 20 over here. What we can observe here is there is another graph which is dropping down, and in between it is suddenly increasing and then it is again dropping down. That is, if we see these 2 points alone, how much growth has occurred between 11 years and 13 years. So within this particular point of duration, how much growth, that is the velocity. Whereas if you see this from birth till 18 years, it is keep on increasing. This is distance. So there are two types of the curve which will tell overall growth, whereas this is amount of growth in that particular duration. So if we can able to measure that, then we can able to compare different individuals based on their growth within the duration. That is, in this picture we can see that blue color triangle is being considered as the individual who had menarche at 10 to 12 years, whereas the round green color dot, this graph line is considered as the individual who had menarche between 12 to 13, whereas the green color square is being considered an individual who had menarche between 13 to 15 years. Let's see the age from 0 till 16 years when they are forming this growth velocity curve. We know it, right? What is velocity curve? In velocity curve, we are going to only use the coordinates of height gain per year, not the overall distance curve. We saw this is a distance curve, how it is gradually increasing. We don't use this curve, whereas we use this height gain only per year. So when we follow that, we can see the blue color and this green color and then this green square. These three people had a different timeline of menarche. Here this person has got it very late, 13 to 15 and a half years old, whereas this person has got it, achieved it much early, which is in 10 to 12 years. This depicts us when the person is early maturing. Their growth also completes early. The peak has been achieved somewhere around the 11 year itself, whereas the person whose menarche was being delayed, that is, it happens mainly due to your change in biological clock or circadian rhythm, that their inherent nature of biological processes being late, then their overall growth is also being delayed. That is how we need to try to interpret what is early maturation, what is late maturation. So if you take their velocity curve and year before their maximum velocity, we can observe the late maturers and then early maturers. Early maturers, everything happens a bit early compared to the late maturers. But this doesn't mean that their overall growth would be retarded. It is just that there is a delay in the process. So these are all some of the key points, and they are all reference books. You can see Enlow's Essential of Facial Growth and Grabatium, again it is a textbook. Anyways, if you would like to refer, you can use it. And then Profit is a good book which you would like to use it for the reference purpose. So keep learning and keep growing. Thanks for watching.